guys, this is an examples video where we're going to be looking at how to make certain piecewise functions continuous. So here's the type of examples that we're going to look at. So we want to find the value of a, so you'll notice both of these piecewise functions have an a in them. So what value of a would cause these piecewise functions to be continuous? So I've actually talked about how to do this in other videos. So if you already have an idea of how to do it, you could always pause this and quiz yourself and then check your solutions in the next parts. Otherwise, if there's an example you want to see, you can always fast forward to it. So let's get into this. So starting with this first one. So really the idea behind this here is you want to make sure that these two functions are equal at this point. That's basically what we're trying to do. So I'm going to take 2x and I'm just going to set it equal to ax squared. This is what I want to have happen. But now I need to do this at this specific point here. So I'm going to plug in the 1. So really what I get then is just 2 equals a, and so that's actually it. That's our point. So this is the point that we're looking for. So then the piecewise function that would be continuous would be 2x, this is for x is greater than 1, and then 2x squared, again for x is less than or equal to 1. If you're not sure, you could always just take a second to graph it to see exactly what this is talking about. So I will leave the graph up to you, but I highly recommend that if you don't believe this. So for this other one, so we're going to use the same idea here. So I need these two functions to be equal to one another. So where I'm going to start is I'm actually going to take the two functions, so 2x plus a over a plus 2, and I'm just going to set that equal to a squared plus a. And I need this to occur at x equals 0, right? Because that's where these two functions are changing. So this is where I need them to actually be equal. So if I plug in 0, what I end up getting is a over a plus 2 equals a. So now I just have a problem in a bunch of different a's. So now I can just use normal algebraic techniques to solve this. So I'm going to multiply each side times a plus 2 so I can cancel out the a's here. So let's see, I'll move this over here. So this is going to give me a equals a squared plus 2a. So this is now quadratic, so I just need to subtract off the a. Oops, and this is a squared plus a equals now 0. So I can factor this. This is going to be a times a plus 1 equals 0. And what this is telling me is that there are actually two different values of a that would work. The two values of a will be a equals 0 or a equals negative 1. Either one of those values would cause this function to actually be continuous. And so you can, of course, plug those values in and test that out just to make sure that that actually works. And that's it for this one. So very quick 2 sets of examples, but if you are looking for more, you can always drop me a comment. I do read comments and I do try to make videos based on what other people need. So that was just kind of a quick overview. Hopefully it was helpful, and I'll see you guys next time.